this is just a continuation of our previous lesson, and this is one of the series lessons that we're looking at the trigonometric functions, how to solve equations that are based on a trigonometric function. In our previous example, we looked at cosine function. So this example, this lesson, we're looking at sine and tangent functions. So in our first example, we have sine 2x equals to a half. And the first thing we need to do is the coefficient of the x. Make sure you multiply on the given domain. So in this case here. And the second step will be 2x. So we need to get the sine inverse of a half, which is going to be 6 pi on 6. Pi on 6. That is the first quadrant, and also remember that sine is positive in the second quadrant as well, so that means 5 pi on 6. So we multiply this by 2, so to give us 4 pi. So that means I have to add 2 pi to that, so add 2 pi to this, so that gives me 13 pi. 5 pi on 6, add 2 pi to it, so that gives us 17 pi on 6. That's it. So now the next thing we need to do is divide both sides by 2. So pi on 12, 5 pi on 12, 13 pi on 12, 17 on 12. And that finishes that example there. So let's have a look at another example on this concept. So this time, again, we just need to multiply the coefficient of theta on the given domain. So that gives me 4 pi. So the next thing I need to do is just to make sure, because we have got sine here and cosine there, and we know that tan is change in y over change in x, so that means sine over cosine. So that means I have to divide both sides by cosine. So that gives me 1, and that gives me, well, that whole lot equals to tan 2 theta equals to 1, and 2 theta equals to tan inverse 1, which equals to pi on 4. And also we need to remember that tan is also positive in the third quadrant. So this is the first quadrant, so that's going to be 5 pi on 4. And we know that this is 4 pi. We need to add 2 more pi to pi on 4, and also I have to do the same thing, and so that gives me 9 pi on 4 and 13 pi on 4. And the next thing I need to do is I need to divide both sides by 2. Pi on 8, 5 pi on 8, 9 pi on 8, and 13 pi on 8. Alright, let's have a look at the other example on that concept. So this time we look at a negative one. Alright, we also need to remember that sine is negative in 2 quadrants. That is the third quadrant and the fourth quadrant. So that means square root 3 on 2 and it's pi on 3. So because this is the third quadrant, so that means 4 pi on 3, and that would be 5 pi on 3. So that means 2 theta equals to and if we add this to negative 2 pi to the left, and the same with that, well, I'll end up getting negative 2 pi over 3, negative pi on 3. And if I add 2 pi on that, so that gives me, what's that? That's 3, 10, just 6. So that gives me 10. 6, 4, 10. That gives me 10 pi on 3. And that gives me 11 pi on 3. So the next thing I have to do is divide both sides by 2. So that gives me 2 pi. It's going to be 3. I just simplified it. Well, you don't have to, but yeah, that's also another way you can just simplify it. All right, now after we're done with this, what we need to do is we need to look at our original given domain, which is this one here, not the one we multiplied with 2. So that original domain is restricted. It's from negative pi to pi. So any value that's bigger than that, we just disregard that. So that is we're not going to take. So therefore, our final answer is, so we put them in order. Ascending order. So that's my solution to that question. All right. And this time we look at the general solution for tangent, but the general solution of sine and cosine we look at in our next lesson. So the general solution of tangent will be x equals to n pi plus tan inverse the given angle, where a is the angle and n is an integer solution. So let's use that concept. So where a is our angle, so that means 2x so that means where n is an integer, and we multiply this by 2, so that gives us 2x negative 2 pi positive 2 pi. Alright, so if I say n equals to negative 2, negative 1, 0, 1, 2, and I substitute back into my equation here, and tan inverse and square root of 3 on 3 is pi on 6, and if I substitute negative 2 to that, so that gives me negative 11. So 2x equals to negative 11 pi. And if I substitute negative 1 into that, so that's going to give me negative 5 pi on 6. And if I substitute this 0, so that's 0, so it's going to be pi on 6. If I substitute 1 to that, so that's going to be 7 pi on 6, and that gives me 13 pi on 6. I divide 2 on both sides, so back to my original domain. So that means I have to disregard this domain, so this given x value, so everything else is a solution to this equation except that. So our given domain is that. One last example on general solution. So we multiply the 3 on the given domain, and the next thing I have to do is divide both sides by cosine. So we're aiming the general solution again. So it's another example for general solution. Tan inverse 1 is pi on 4. And if I make n as to be starting from 0, 1, 2, 3, then 4, and I sub it in back into my given equation here. So 0 gives me a quarter pi, and that gives me 5 pi. If I substitute 1 into that, that gives me 5 pi on 4. 2 pi, so that gives me 9 pi on 4. 13 pi on 4. 17 pi on 4. And 21 pi on 4. And I divide 3 on each side. Alright, that's it for this lesson, and in our next lesson we look at the general solution of cosine and sine.